All right, let's go ahead and do some practice problems with empirical formulas. And before we get started, I want you to write down this poem that helps us with doing these problems. And so the poem is percent to mass, mass to mole, divide by small, multiply till whole. And so go ahead and pause the video and write down this this poem here, because we will be using it to help us with these practice problems. All right, so let's go ahead and take a look at what this problem is telling us. It says a qualitative analysis shows that a compound contains 32.28% sodium, 22.65% sulfur, and 44.99% oxygen. And it says to find the empirical formula. The way that you do these problems is the first thing you want to do is label the elements that you're dealing with. So we have sodium, we have sulfur, and we have oxygen. Then you want to write what's given to you. So we're given 32.28% sodium, 22.65% sulfur, and 44.99% oxygen. And so what we're about to do is we're going to use our poem to help us, to guide us through this problem. And then I'm going to explain each part as well as we go. What I will say is you want to do this each step to each element as we go. You don't want to just do one element. You want to do the same step to each one as you go. And so the poem says percent to mass. So if you look at the poem, it says percent to mass. That's the first thing we want to do. Well, what that means is we're going to take the percentage and we're going to just change it to grams. That's literally what you do. And the reason why we do that is because, like in the notes, it says that we assume we have 100 grams, right? So if we had 100 grams and 32.28% of it was sodium, that means we would have 32.28 grams of sodium. So because we assume 100 grams, we can just take the percentage and turn it to grams. So first step, percent to mass. Literally just take the percentage, make it grams. Step 2, mass to mole. Okay, so we have our mass, and what we do is we go from mass to mole for each one here. Just take the grams, convert to moles. Sodium molar mass is 22.99. Sulfur is 32.064, and oxygen is 15.999. Let's go ahead and type that in our calculator. And when you do that, you end up getting 1.4, 0.7, 2.8. Now, when we have a formula, let's say glucose, what these numbers here, they do tell us the number of atoms in the molecule. However, it also is a mole ratio. That 6 moles of this will be with 12 moles of that, and 6 moles of that. And so it's a 6 mole to 12 mole to 6 mole ratio. And so when we convert these to moles, we can then figure out the molar ratio, just like this. These are molar ratios. We can figure out the molar ratio. And to figure out that ratio, what you do is you divide by the small. So we took the percent to mass, we took the mass and converted it to moles. Now we're going to divide by the small, and that's going to help us find the mole ratio. And which one of these is the smallest? 0.7 is the smallest. So you divide by 0.7, divide them all by 0.7, and this is going to be 1. This is going to be 2. This is going to be 4. And so we end up with 2, 1, and 4. Now what I will say is, if you get something like this, if you get something like 1.99 or even 1.97, that's pretty much 2. All right, that's pretty much 2. If you get something like 2.10, well, that's actually not 2. That's pretty far. If you get something like 2.07, that's pretty much 2. The rule is if it is within 0.1, if If it's within 0.1, you can round it to that. Now let's say you get 2.49. Well, this is essentially 2.5. If you get let's say 65, that's essentially 2.67. And the reason why it's 2.67 is because that's 67 is about 2/3. And so you got to kind of have the mindset of that this is going to be close to some sort of fraction. And what I mean by fraction is this is close to a half. This is pretty much close to a third. This would be close to a fourth. All right, but essentially we get 2, 1, and 4. Now what that is, that's a mole to mole, those are molar ratios. It's a 2 to 1 to 4 ratio. In this last step here, if you take a look, the last step is multiply till whole. And what that means is if you do not have a whole number, then what you would want to do is multiply it to a whole. What I'll say in this first situation, we have only whole numbers, so we actually do not need to multiply to a whole. But to give you an example, if this was 2.5, well, we would have to multiply this to a whole. So if this were 2.5, what you would do is you would multiply this by 2 to make it whole, which would be 5. If it were 2.33, let's say, you would multiply it by 3, and that would give us 7. If it were 2.25, you'd multiply it by 4, and so on. If this were 2.5 and you had to multiply it by 2 to get 5, well, you'd have to multiply everything by 2, and so on. And so if you had to multiply by 3, you'd have to multiply everything by 3. But in this situation, we do not need to do that because they are already whole numbers. Now what we then do, now that we have our whole numbers, what that means is that sodium, there's 2 sodiums. There's 1 sulfur. There's 4 oxygens. And look at that. It's Na2SO4, which is sodium sulfate. All right, let's go to the next one here. All right, so we have phosphorus. We have oxygen. Now it says that a sample, that is 10.150 grams of a compound known to contain phosphorus and oxygen, indicates a phosphorus content of 4.433 grams. And so 4.433 grams. Now, it is asking for the empirical formula, so we need to do percent to mass, mass to mole, divide by small, multiply to whole. However, it does not give us the oxygen content. It does give us the total, though. So this compound here is 10.150 grams of phosphorus and oxygen. Now, if phosphorus is 4.43 grams, what must the oxygen be? Well, this is both the phosphorus and the oxygen. Again, this right here is both the phosphorus and the oxygen. So all you need to do is subtract this from the 10.150, and that'll give you the amount of oxygen. What you end up with is 5.717 grams of oxygen. All right, so our poem is percent to mass. Well, we're not given percentages. We're given masses. So we actually skip that first part. We're already in step 2. We don't need to do step 1 because it doesn't give us percentages. It already gives us grams. So if it already gives us grams, then that's what we get to use. Then we do mass to mole. Okay, let's go from grams to moles for each one of these. Phosphorus is 30.94, I believe. 974. And then oxygen 15.999. And then you just type that in your calculator. And you end up getting this for each one. So, okay, we did percent to mass. Okay, we already had mass, so we didn't have to do that. Then we went mass to mole. Now we divide by the small, and this one is the small. Notice how whenever you divide by small, you'll always get one that's equal to 1. and you end up getting 2.49. You get 2.49. What is 2.49 essentially the same thing as? It's the same thing as 2.5. All right, then what we need to do is multiply till whole. This is not a whole number, so what do we need to multiply by? We got to multiply it by 2. But if we multiply this one by 2, we have to also multiply this one by 2. And what we end up with is 2, 5. So that means that phosphorus, there's 2 of them. Oxygen, there's 5 of them. And so the empirical formula for this is going to be P2O5. And that's the answer there. Now notice that happens to be the compound in the next problem. Oh, it's a weird coincidence. All right, so again, when you do this percent to mass, mass to mole divided by small multiplied to whole, when you do that, you are getting the empirical formula. And the empirical formula is the most reduced ratio of the compound. And so this is a 2 to 5 ratio. However, if you take a look, this one's asking for the molecular formula. And these problems are super easy. You take the molar mass of the molecular, so I'm going to put molar mass of molecular, and you divide it by the molar mass of the empirical. Let me just put EMP for empirical. This will always be given to you. Notice how it is given to you. This, you just need to figure out the molar mass from the empirical formula. You just add those up and you'll get the molar mass for that. And what you end up with is 141.94 when you find the molar mass of that. And when you divide this, it will always give you a whole number. And in this situation, it gives you 2. It's a whole number of 2. Now let's think about what this 2 means. What this 2 means is that the molar mass of the molecular formula is 2 times as much as the molar mass of the empirical. So if this is the empirical formula, how do we make it 2 times greater? Well, we multiply the subscripts by 2 to where we get this. And that is our answer there. Go ahead and do the next guided practice problem. I'm not going to include it in this particular video because I want you to give it a shot on your own. But what I'm going to say is this one right here is essentially problems 2 and 3 put together. And so I want you to try to figure it out. So I'm going to put the answer. I'm going to post the answer on the answer key. And I'm going to have the worked out for you, but I want you to give this one a shot on your own to see if you can do it. This right here is telling you the molar mass of the molecular formula. And so you take your grams, you convert it to moles, divide by small multiplied to whole to get your empirical formula. And then what you do is you divide it into the molar mass there to get the number that you have to multiply it by. So again, number 4 here is essentially numbers 2 and 3 put together. Go ahead and try it on your own, and I'm going to post the answer on the Schoology there with the answer key to the rest of the problems. You guys have a great day.